Hello and welcome to the lesson that we went over today. This is Monday. I know a lot of you were having some problems with Zoom, so I said I'd put a video up. So here is the video. This is going to be a crash course. It's just going to go kind of super fast through it. Feel free to stop, rewind, all that good stuff if you need to. So we went over three basic things today. One was the language of math, just kind of going over why it's important for us to go over today's lesson, basically. A couple definitions, and we went into expressions, not even necessarily algebraic, but just expressions overall. Okay, so first thing is language of math. Everybody was coming to me from different math teachers, so I needed to kind of figure out what you were taught, what you were familiar with, and just different ways that you were taught the math language. So I kind of liken this to all of these different foreign languages. So if I was going to show you any one of these words, I need to know, like, do you know what any of this stuff means? There's three different languages. Here's a fourth one. Here's a fifth one. And then here's another symbol. So it turns out all of these mean the exact same thing. They all mean shoes. So even though the concept of a shoe is a very simple concept, depending on what your previous experience was with the different languages, means that if you saw this language right here and you had no idea what it meant, that doesn't mean that you don't know shoes. It just means that you didn't have that experience with that language. Same thing with this language, even this one. But the one that probably resonates with most people is the actual picture of it. So basically, what I'm trying to do today is trying to get to know what your previous language in math was and trying to get everybody to the same spot as far as everybody understands what a shoe is. Okay. So that's kind of an analogy of what today's lessons kind of the basics of it. So if we take a look at these five different expressions, these are called expressions. Um, what I had the class do was basically share out what they thought each one said, like out loud. We had people saying this was 3 plus 7. This was 3 added to 7, x subtract 9, x take away 9, 3x plus 4, 3 times x plus 4. So people were saying different things for all of these. And it was kind of becoming clear, like people had different kind of viewpoints of what each one said. So we had to come to kind of agreement how we were going to say each one of those, as well as how we would know what each one meant. So a couple definitions that we went over. First one was quantity. In your textbook, the definition is anything that can be counted or measured. So basically, that's almost everything. So if you think about counting the number of insects outside, if you think of you want to count the hairs on a dog, if you want to count how many ice cubes there are in the refrigerator or freezer, um, or if you want to measure temperatures, if you want to measure how deep something is. So anything that you can basically assign a number to is a quantity. All right. Now, a variable is a type of a quantity. It's a quantity that can change. So my analogy that I used in class was if I went around my entire classroom and said, I'm going to give everybody some money, and that money is going to be double whatever's in your pocket right now. So that would be like two. Doubling means you multiply by two. So I'd do 2 times whatever's in your pocket. Now, the thing that would be the variable in that case would be the money in people's pockets, because depending on who I was talking to, people, different people in the class might have different amounts of money. So the money in your pocket would be the variable piece, since that would change from person to person. So the actual textbook definition would be a symbol, usually a letter, that represents the values of a quantity that can change. So like I said, the quantity that would change in my example would be the amount of money in your pocket. Multiplying by 2 stays the same. So times 2, that's the quantity that stays the same. The variables, the amount that's in people's pockets. Since some people, like myself, don't have any money in their pocket right now, so I would get $0, which would be very sad. The next part, that was a definition as far as expressions go. In math, there are two types of expressions, or at least in our class, we're going to have two main expressions types that we're going to see. One is called a numerical expression. Numerical expression is a mathematical phrase involving only numbers and operations, no variables. So a dead giveaway that it's numerical is that you only see like 6 plus 5. You only see numbers and an operation telling you what to do with those numbers. You're not going to see any letters, so no variables. The other type of expression is an algebraic expression. These expressions do have variables. So they are basically just like a numerical expression, but now you got some letters thrown in there. And then, hold on. Okay. And then I went into a couple examples. So for example, if I wrote down 7 plus 9, since all I see here are purely numbers, okay, and then an operation of addition, that is called a numerical expression because I don't see any letters going on here, no variables present. But if I all of a sudden put a y on there, now I have an algebraic expression because now I have variables in the mix, okay? And that's true too if I had like a 4 minus 6 plus a y, that's still going to be algebraic because it has a variable. But if it was just 4 minus 6 without the y piece, that would be numeric. I think I said that backwards. Oh, sorry. So with the y, it is algebraic. Without the y, it would be numerical. All right, so that was that piece. Then we went into algebraic expressions. And I still haven't changed it. I meant to say just expressions because I think a couple of these examples are numerical as well. So basically our goal today was I would give you a phrase. So 8 plus a number x. You had to act like you were some type of translation machine. Like I said, it's like it's a foreign language. So you got to act like you're translating it into a mathematical language, which looks like this. This is our expression, okay? Algebraic because it has an x. So basically we're going from a sentence or a phrase into an algebraic expression or numerical expression. And then on your homework, I also have examples where you go from a numerical or algebraic expression back into a sentence again. So basically we're just kind of going round and round with these two different ways of writing the same thing. They mean the exact same thing, just like how I was talking about the shoe. These two mean the same thing. It's just different languages, basically. All right, so first example we went over in class, 9 divided by a number y, a little bit of a strategy that you can use here. First, you're going to look for numbers and variables, then look for the operations to connect them together. So the numbers are variables, also known as quantities. First quantity that I find is a 9. I'm going to write down a 9. Next quantity that I see when I read that is y. Y is a variable quantity because it's still a quantity. It's just variable because it's a letter. So I got my y. Now I got to figure out, okay, what am I doing with these two quantities? That's where the operations come in. When I say operations, I'm talking about adding, subtracting, multiplying, dividing, those type of things. This one's pretty obvious. It actually says divided by, so I know there's a division. So I put 9 divided by y. Now, most of the time, the place where people mess up, if they mess up, is that they flip-flop this. They put y first and then the 9. The order does matter. So the vast majority of the time, you're just going to write the quantities in the order that you see them. So I saw the 9 first, so I'm going to write the 9 first. I saw the y second, so the y is the second part. I just put divided in between those two. Okay? So let's try that with another example. Same thing here. Find out your quantities first. My first quantity is an x. Second quantity is a 17. The operation, that's all for the quantities. I don't see anything else there. The operation is a sum. Remember, sum is another way of saying adding. Now, same thing. Make sure you write it in the correct order. So that's going to be x plus 17 because I saw the x first and then I saw the 17. All right. Some people were trying to write the 17 first in class. While that's technically correct because addition is commutative, I don't want you flipping stuff over or anything like that unless the verbiage or the wording of it calls for it. So leave it in the order that you see it unless you see the two exceptions that I will go over later. Okay, so in this case, just leave it in that order. First put your x, then put your 17. All right, so next thing we did was we actually went into Desmos. I had everybody share out all the different ways they've learned adding, subtracting, multiplying, and dividing. Then we came together and shared it. But but let's go ahead and skip over that and go into the main ways that you'd see it in my class. So add, you'll see the phrase added to, plus, more than. Those all mean adding. Those are definitely not the only things that mean adding, but those are some of them. Subtracting, you'll see minus, subtracted from, take away, less than. There are more than that as well, but these are the main ones that you'll probably see in my class. Multiplying, product, times, double, triple, etc. Etc. Meaning quadruple, things like that. That type of verbiage just means that you specifically have to multiply by a certain number. So double means multiply by 2, while triple means multiply by 3, quadruple means multiply by 4, etc., etc., etc. So next thing up was dividing. Quotient divided by half, thirds, fourths, fifths, sixths. Okay, those all mean divide. Now, there's a reason why I put asterisks on there. That's because I will accept other variations of this. What I mean by that is this. For example, if I saw a sentence that said half of 17, I would expect a lot of people to put 17 divided by 2. That means half of 17. 17 over 2, that's also half of 17. But half doesn't necessarily have to mean divide. It could also mean multiply. So half of 17 is half of 17 because 1/2 of 17 is the same thing as multiplying by 1/2 by 17. So on a test, I would accept any one of these three. Technically, well, I'll accept all three of these. So just be aware of that. If you see halves or thirds or things like that, I would not only accept it as a division, I would also accept it as multiplying by a fraction. All right. Now, I had said that you should write these things in the order that you see them. The exception to that is when you see more than or less than. Just the way that that verbiage happens means that you should be flipping it around when you're doing math. Okay. So let's say that I had $6 less than you have. That means I take your money and then I subtract 6 from your money, and then I'll have more my money. So that less than and more than, it flips it around. Here's the example I showed in class. So 12 take away 8 and 12 less than 8. Both of these examples are examples of subtraction. But because this says less than, this one should be flipped over. Like this one right here, 12 take away 8. I'm just going to write it the way that I see it. 12 take away means subtract, and then 8. So 12 subtract 8. For this other one, when I see this less than, that should put a big red flag in your mind saying, okay, wait. This is what Mr. Gary said I have to flip. So less than still means subtract, but you're going to write your 8 first and then your 12. Okay, so just be aware of that. More than and less than means that you're going to be flipping stuff over. All right, so then what we did is we did some U-tries. We broke into breakout groups. People were trying these ones out. I'm going to show the answers for each one of these. Feel free to pause the video, try them out yourselves, and then check with this. There are more than one answer here, so the answers that I'm showing definitely are not the only ways you can write these, but this is probably the most common way. So if I see, so go ahead and try it. Push play again when you're ready to see the answers. 16 more than K. So again, more than, that's one of those instances when I know I'm supposed to flip it over, so I know the K should be first and then the 16. More than means I'm going to add. So K first, then the 16 should be adding. K first, 16, add them together. There you go. Quotient of 8 and 10. So I know I got an 8 as one quantity, 10 as another quantity. Quotient means I'm going to be dividing those two. Just write it in the same order that I see it. I can either do 8 over 10. Another way to do it is 8 divided by 10 like that. These mean the same thing. I'd be giving you full points either way you wrote that. Okay, you don't have to write it both ways, but just know that both of those are okay. This next one, I actually see 3 quantities. I got an 18, I got an X, and I have a Y. So I should have more than one operation here. And I see a plus and I see a product. 18 plus the product of X and Y. So I know I have my 18. I'm going to add it to the product of X and Y. So everything should be in the same order. Product means multiply. So one way that I might see that is like this: 18 plus the product of x and y. Um, I might also see a little dot in between these to show x times y. That's fine. A lot of people were using parentheses. That's fine as well. There's a lot of different ways to show products. But yeah, this is probably one of the main ways I'd see it. The difference of y and half of 12. Difference means subtract. I don't need to flip anything over because I don't see any more than or less than. So difference means I'm subtracting. So I'm going to do y. The difference of half of 12, half, there's a few different ways you can write it. I would probably write it like this: the difference of y and half of 12. Okay. Um, and that was that one. And basically, I just told the whole class that you would also be expected to take a look at work backwards as well. So being able to look at this expression and then write a sentence from that expression on your homework as well. Okay. Again, there's more than one answer on these. So just be aware of that. I'm going to release the answer key. So if your answer doesn't quite match the answer key, don't kind of sweat it. It still might be correct. Just check it with me. All right. And that was the main stuff that we went over for today. If you have any questions, feel free to stop by during tutorial or let me know through an email. All right. Hope everybody's doing well. Take care. Bye-bye.